Alrighty, so we're trying to graph 1 over f of x. They've given us f of x, yeah?
Yeah.
Step 1, whenever there's a 0 at f of x, there's going to be an asymptote for 1 over f of x.
Yeah.
So that's our first point. Second point, the asymptote, the y-intercept. The y-intercept here is -1, right?
Yeah.
So the y-intercept for 1 over f of x is going to be 1 over -1, which is still -1. So this point stays where it is.
Okay.
And similarly, you see this point? What's the y value here?
1.
1, right? So the reciprocal function will be 1 over 1. So that point also stays where it is.
Okay. Yeah.
And now we can just pick out a couple of points. 1 over -4, yeah?
Yeah.
-4 is going to be -0.25. So that point is going to jump up there.
Okay.
1 over -3 is -0.33. So that point is going to jump there. Okay. And again, this point, I'm just going to assume it's like -0.01.
Yeah.
And 1 over -0.01 is a big negative number, like a -100 or something. So that point is going to jump all the way down there. And now we just connect the dots. And we know there's one asymptote, so there's going to be 2 parts to the reciprocal function. Yeah. And similarly, on the other side, we do the exact same thing. That point stays where it is. This is positive 0.01, yeah?
Yeah.
1 over positive 0.01 is like 100, so it's going to jump all the way there, right? And then we have 1 point, we have 2 points, and then we can just pick out a couple more. 1 over 4 is 0.25, so it's going to jump down there. 1 over 3 is 0.33, so it's going to be slightly higher than 0.25. And now we just connect the dots. And there you go. Okay?
Yeah.
So that is 1 over f of x, the one in red. So that's a linear one. Linear we've done before. Let's do some other ones that we have not done. What if it was this one? And by the way, you notice even though we had a linear, yeah?
Yeah.
See, our reciprocal function was curvy.
Yeah.
Right? So even though these are straight lines that we're starting off with for B in part B, the reciprocal function would still be like curved.
Okay.
Okay, what's the first step?
Find the zeros, and those will be the asymptotes.
Exactly. So there's zeros at +3 and -3. So those are going to be asymptotes. So now see there's 2 asymptotes. This means the graph will be divided in 3 parts.
Yeah.
The next part, the y-intercept is -2. So it's going to be 1 over -2 minus 0.5. So up there. Okay, and now we can just pick and pluck some points. What's a nice point? This is 1. Yeah, this point stays where it is because the y value there is -1. Yeah.
Yeah.
So 1 over -1 is -1. Same thing on this side. And now I'm just going to assume that this is like -0.01. So that's going to drop down to like -100 or a big negative number.
Okay.
And now we connect the dots and that will give us a curve. Even though we started off as a straight line, we're going to get a curve. And that's one part done.
Okay.
Yeah, see here, you don't have to be very precise.
Yeah.
Now we're going to do the exact same thing on the other side. So this is 2. 1 over 2 is 0.5. So that point is going to jump down there. Yeah?
Yeah.
This is 1. The y value there is 1. So 1 over 1 is 1. That point stays where it is. And this I'm going to assume is like 0.01. It's going to go all the way up there.
Okay. Yeah.
And then we have this thingy on the right side. And then we'll have the exact same thing on the left side. That point stays where it is, right?
Yeah.
And then what else? This is 2. 1 over 2 is 0.5. And then I'm going to assume that is 100. And then there we go. So 2 asymptotes, 3 parts to the graph.
Yeah.
It's not that bad, right?
No, I think like once I keep doing it, it's not going to be that hard.
Yeah. D is very similar to B. We don't have to do it. Let's do C. So again, when there's zeros in the parent function, we will have asymptotes in the reciprocal function, right? So I'm just going to draw the reciprocals out, and the y-intercept here is 6. So 1 over 6 is like 0.18, whatever. It's going to jump down there. That point is 1 over 6, okay?
Okay.
That's the y-intercept. And now we just do what we did before. You see this?
Yeah.
This is 1. Y value there is 1. So that point is going to stay where it is. Yeah?
Yeah.
And then just to the left of the asymptote, the y value there is a very small positive number, yeah,
Yeah.
0.01. So that point is going to jump all the way up there.
Okay. Yeah.
Same thing on this side. And then we have this, and now we can just connect the dots. We can do one more point if you want. So 4 is there, so that's going to be 0.25. 1 over 4 is 0.25, so it's going to be higher than that. So where's 4? It's right there. It's going to be 0.25.
Okay.
This is going to be 0.5. Same thing here. At 2, it's going to be 0.5. At 4, it's going to be 0.25. Now we have all the points that we need. We just connect the dots. It's not going to cross the asymptote. It's going to look something like that.
Okay.
All right, it's not that bad.
Yeah.
Just do it like a few points at a time and it should be pretty simple.
Okay.
What I'm going to tell you is this. Yeah, let's briefly talk about this because this is the hard part.
Okay.
So far we've been doing reciprocal functions, okay?
Yeah.
Now we're going to be doing a rational function.
Okay.
So a rational function is when you see a linear in the top, a linear on the bottom. Before we only had a linear in the bottom, yeah?
Yeah.
So to do this, we first have to come up, let's first find the intercepts.
Okay.
So where is the y-intercept? So the y-intercept is when x is 0, yeah?
Yeah.
So we just find f of 0, right?
-5 and over 2.
Yeah, so -5 over 2, that's -2.5.
Yeah.
So right there is our y-intercept.
Okay.
Let's find the x-intercept. The x-intercept is when the y value is 0, right?
Yeah.
So 0 equals 3x minus 5 over x plus 2. By the way, I didn't do this thing with you, like the positive, positive, positive. Are you familiar with this? The sign chart?
No. I think we might have started that yesterday, like when we were doing like the ranges between like for certain answers, but I haven't seen that.
Okay, so actually you have to understand this to understand this, all right?
Okay.
So I'll just do this just so you know. Here you see there's an equals to sign. So you're allowed to multiply both sides by the denominator, okay? But in this unit, in the inequality unit, you would have something like this. In this, you cannot multiply both sides by x plus 2 because x plus 2 could be a negative number, right? And if you multiply by a negative number, the sign flips. So when you're doing inequalities, you're not allowed to multiply both sides by x plus 2.
Okay.
To do this, you're going to have to make a sign chart. Okay, but here it's an equation, so we are allowed to multiply both sides by x plus 2. So x plus 2 times 0 is 0, you get 3x minus 5. So the x-intercept is 5 over 3, which is 1.66, right there. Okay?
Where does the x plus 2 go?
Oh, I multiplied both sides by x plus 2.
Okay.
So I get 0 equals 3x minus 5, right? So x is 5 over 3.
Okay.
So step 1, find the intercepts, x and y-intercepts. Step 2, you're going to find the vertical and the horizontal asymptotes. Now look at this. Vertical asymptote is when the denominator is 0, yeah?
Okay, yeah.
So what value of x makes the denominator 0?
-2.
Exactly. So vertical asymptote is x equals -2.
Okay, yeah.
Right there. Okay.
Mm-hmm.
Now the horizontal asymptote, this one's a little bit tricky. For this one, so you see the degrees are the same in the numerator and the denominator, yeah?
Yeah.
So if the degree in the numerator is equals to the degree in the denominator, the horizontal asymptote is at the ratio, yeah, the ratio of the coefficients. So what's the leading coefficient in the numerator?
3.
3. What's the leading coefficient in the denominator?
1.
1. So your horizontal asymptote is at y equals 3 over 1, which is y equals 3.
Oh, okay.
So there we go.
If they were of different degrees, then what would you do?
Then there's different conditions. So if
Okay.
the degrees are the same, then y is going to be the leading coefficient of the numerator, yeah,
Mhm.
over the leading coefficient of the denominator. This is what we did here to get 3.
Yeah.
If the degree in the numerator is less than the degree in the denominator, for example, 1 over 2x minus 1,
Okay. Yeah.
then the y asymptote, horizontal asymptote is at y equals 0
Okay.
every single time. And this is what we had, right, in the previous questions that we did.
Yeah. Yeah.
Notice we always had y equals to 0 as the horizontal asymptote, no x-intercept, because the degree in the numerator was less than the degree in the denominator.
Okay.
And if the degree in the numerator is bigger than the degree in the denominator, yeah,
Mhm.
like for example, x squared over x plus 1, there is no horizontal asymptote.
Okay.
Okay, so 3 conditions.
Okay.
But here condition 1, when the degrees are the same, we just took the ratios, yeah?
Yeah. Yeah.
So at 3, we have a horizontal asymptote. So we did the intercepts, we did the horizontal asymptotes, and these types of questions, it'll always be like something here, yeah?
Okay. Yeah.
And then something like here, or the other way around. Something here, and then something here. Okay,
Okay.
two possibilities, here and here, or here and here. Yeah.
Does that is that like based on if the leading coefficient is positive or negative? Like which one?
It changes from time to time. So what gives it away? Yeah, we don't even have to do any more math here. You see, where are our intercepts? It's down here, right?
Yeah.
So this question must be this one.
Oh, okay.
So now I'm just gonna join the dots. So it's gonna look something like this. So it's not gonna cross that asymptote. We have this here. And since we don't have a y-intercept above 3, right? The other half must be here.
Okay.
And there we go. This is the sketch of this rational function.
Okay.
Now let's answer the question. It's asking us how this graph approaches its vertical asymptote, okay?
Mhm.
So the vertical asymptote is at x equals -2.
Yeah.
So how would we answer this question? So there's 2 parts to this question. We got to look at from the right side, okay?
Yeah.
We got to look at it from the right side. So as x approaches -2, okay, here, now look at the notation here. As x approaches -2 from the left side, that's why I put a minus sign there. Yeah.
Yeah.
Y is going to positive infinity, right?
Uh,
See this,
yeah.
this?
Yeah. Okay.
And when
Yeah.
x is going to -2 on the right side, I'm going to put the plus sign, okay?
Mhm.
As x is going to -2 from the right side, where's y going?
To negative infinity.
Yeah, there we go. And that's the answer to this problem.
Okay. But why didn't like when you drew the one on the bottom? Why
Yeah.
didn't it go all the way to the asymptote? Like why'd you
Oh, it
stop?
does. It goes like right there. It doesn't cross it.
No, no, no. Like but above, like it. You see how the other one goes really close to the top? How come this one doesn't? Is there like a restriction there?
I'm not sure where, like here?
No, no. Like towards the center.
Oh, here?
Yeah. Like why doesn't it go all the way to where the dotted line crosses?
Uh, because you see, I just joined these 2 dots.
Oh, okay.
Yeah, so it's not gonna go through like there.
Okay.
I was looking at these 2. That's why.
Okay.
The x-intercepts and the y-intercept, right?
Okay.
Yeah, but this is how you'd answer this question. -2 from the negative side and -2 from the positive side.
Okay.
And you do a lot more of this in like the next course.
Okay.
Okay.
Okay. Thank you.
All right, I'm gonna upload this video on YouTube.
Okay.